Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2014 Calculus BC exam question number 4. This question also made a cameo appearance on the 2014 Calculus AB exam as well. It's a standard table problem with a little bit of a twist at the end, so let's go and take a look at it. The problem reads as train A runs back and forth on an east-west section of the railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function, v sub a of t, where time t is measured in minutes. Select values for v of a of t are given in the table above. So part A, pretty straightforward. Find the average acceleration of train A on 2 to 8. So the average acceleration will be v of 8 minus v of 2 over 8 minus 2. That's going to get me negative 120 minus 100 over 6. That will then simplify into negative 220 over 6, giving me negative 110 over 3. So pretty straightforward kind of problem right there. Part B, it says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time within 5 to 8? Give a reason for your answer. Okay, so I'm given a table of velocity, and I want to know if the velocity is equal to a certain value on a certain interval. To me, that screams intermediate value theorem. So what I'm going to do is I'm going to say, all right, well, what is v of 8? v of 8 is negative 120, which is less than the targeted velocity that they want me to find. They want me to find out if it's negative 100, right? So v of 8 is negative 120. That's less than negative 100. v of 5 is equal to 40, which is definitely greater than negative 100. So what I can say then is I can say, and I'm actually going to type this out here, is I'm going to say, because it tells me that v is a differentiable function, so I'm going to say v of t, and there should be a sub a there, I'll draw that in a second. v sub a of t is differentiable and therefore continuous on 0 to 12. Therefore, by IVT, there exists a time on 5 to 8 where v of t would equal negative 100. Oh, too many signs there. Whoa. Negative 100. So typical intermediate value theorem question right there. So establishing the continuity is going to be the key to that problem. If you don't, you're not going to be eligible to earn those points. Part C, it says at time equals 2, train A's position is 300 meters east of origin station. What they're giving me is they're giving me an anchor, 2, 300. It says the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time equals 12. So from here, if I integrate, I'm trying to find out the location at time equals 12, so I'll end my limits of integration at 12. I'll begin it at 2 of v sub a of t dt, and I told you guys I would put in sub a's here, and I did not do that. So sub a, okay, cool, I think we're all caught up. Based on the first fundamental theorem, I will get x sub a of 12 minus x sub a of 2. Now, one of these values I already know. The x sub a of 2 is 300. So that tells me that x sub a of 12, the position of the train at 12, is going to be 300 plus the integral from 2 to 12 of v sub a of t dt. And the next part of the question is they're going to actually ask me to find out what that location is. So for that, I'm going to go ahead and graph this function here. And then I'll add up a bunch of trapezoids. So at 2, my velocity is 100. At 5, my velocity is 40. At 8, my velocity is negative 120. and at 12, my velocity is negative 150. And again, they want me to use a trapezoidal sum on this thing. So I'll go and draw my first trapezoid there. My second trapezoid is going to be some weird-looking double triangle, half over, half under trapezoid, but we can deal with that in a second. And so when I go to add this thing up, I'm going to get 300 plus, so 1/2, my first base is 3, and then base 1 plus base 2 is going to be 100 plus 40. And then I'm going to do 1/2 times 3 again for my second base. This time my base 1 is going to be 40. My base 2 is going to be negative 120. And then plus 1/2, my next base is going to be 4. And then my base is going to be negative 120 minus 150. And again, on the AP exam, you can go and leave your answer unsimplified. In fact, I would encourage you to do it, but if you really had the time or just wanted to show off, you would get negative 150. So train A's position at t equals 12 is 150 meters west of the station. All right, let me go and clean up the board real quick, and we'll finish this thing with part D. Part D says a second train B travels north from origin station. It says at time t, the velocity of train B is given by v sub b of t equals that thing. And at time equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B's is changing at t equals 2. So here we got the origin station. We got train B leaving northbound here. We got train A leaving presumably east or westbound. The trains are going to be at some point right there, at some point during their journeys. And I want to measure the distance between them. So I'll just go ahead and call that, for lack of a better term, C. And I want to find out how much this distance, this diagonal hypotenuse-like distance is changing. Well, to me, this sounds like a related rate problem. And once I establish the rate that they gave me, which is going to be the v sub b of t and the v sub a of t, I have to come up with a relationship. Well, that's going to be a squared plus b squared is equal to c squared. And what they want from me is they want dc over dt at t equals 2. So let's take the derivative of this. So I get, with all the 2's canceling each other out, I'm going to get a dA over dt plus b dB over dt equals c dc over dt. Now, it's important to know that the a's, like this a and this b, this is position. This is x sub a, this is x sub b. These rates, unimaginatively, are the velocities, v sub a, v sub b. All right, so let's make sure we keep that in mind. So x sub a, well, what is the position at t equals 2? We want these things at t equals 2. Well, what's the position of train A at t equals 2? It's 300. They told me that in the problem. What is the velocity of the train at t equals 2? It's 100. I got that from the table. So if you look at the table, you'll see the velocity is 100. Well, what is the position of train B? Well, it's 400. They told me that in the problem. Well, what is the velocity at t equals 2? Well, that's going to require some doing. That's v sub b of 2, and we'll figure that out in just a second. Is equal to c. We don't know what that is. But dc over dt is what we're trying to find out. So let's find out what these last two pieces of information are. We don't know what they are yet. Well, what's v sub b of 2? Well, that's negative 5 times 2 squared plus 60 times 2 plus 25. That ends up becoming a total of 125. So we can go and punch that thing in. So 300 times 100 plus 400 times 125 is equal to something times dc over dt. Well, what is this something? Well, remember, at the moment in question, this distance here, this train A, is 300 meters away. This distance here, train B, is 400 meters away. And if you use your similar triangles from integrated 2, then you can conclude that it's a special, not a special right triangle, but a Pythagorean triple making the hypotenuse 500. And once you divide by the 500 on either side, and again, I would encourage you not to simplify anything, just to keep things easier for you, what you'll end up getting is you'll end up concluding that dc over dt is equal to 160 if you decided to simplify. If not, I would encourage you to leave the answer in the unsimplified form just to save time. And I think that will conclude this soiree of FRQs. This was the last one. So if you have any questions, as always, please leave them in the comments section of the video. And I will see you in the next episode.